Good morning and welcome back again. This is another piece of work that I want to hand up. So again, I'm showing you the examples of these questions, so there's no excuse for saying, oh, I can't do these. So if you watch the video and follow me through the questions, well then you have a chance of doing the questions. If you don't understand it once, look at the video twice. So I'm going to do Test Yourself chapter 34. I'm doing pages 413, 414, and I'm doing roughly questions 9 to 10. The purpose of this will be for you to look at this video, learn how to do the questions. I'll show you and highlight the tricks. Then you do the questions on an A4 page to a very high standard. No old rubbish, please. Country's full of rubbish. I don't need any more. I want it done to a high standard. I want it uploaded on a nice plain flat view that I can read it. I'll mark it and I'll send it back to you. This will be recorded. This will be time bound, so in hours I'm going to give you a mark for it. It's going to have a certain time on it. You have to have it done before the time or you get 0. And I'll send it back to you. Fair enough? So now I know where we're going. So I'm going to page 413. I'm going to question 7. And it says, copy and complete the table 34.3. So again, this is the skill of doing the table properly. So you copy a table. I'm not going to copy it, but you copy it and I'm going to talk about it. So radiations in 1. So there's alpha, beta and gamma. It tells the atomic number. Decreases by 2. And then the mass number, what happens it, and then the beta particle, it's unchanged. So it's giving you language within the table that you can use. Have a look at I'm looking at page 413. You should be looking at page 413 and listening to this video, watching the video. But it tells you the language to use. So remember, A cross zebra, and that tells you the number of protons. And remember, A cross zebra is just a mnemonic. And this is the number of, now get your teeth around this one, nucleons, protons and neutrons, P's and N's. Yes? So we're going to fill in this table, but you're going to draw the table better than me. Well, I might draw it. Depends on how I feel in a minute. We're going to talk about alpha. I'm going to talk about beta. I'm going to talk about gamma. I'm going to write the symbols down. And again, if you don't know the symbols at this stage, learn them. So sometimes this pen likes to draw straight lines and then sometimes it doesn't. What do we do? Oh, today it does. Right, so we're in a horse. So there's the table. Again, I'm doing this in a virtual world, so you should be able to do it much better than I, because you're in the real world. Well, some of you are. So there's the table, all done. So you can get back over to the corner here. Please, machine, come follow me over. Stop following me over. Right, so what happens to the atomic number Z? And you losing that, right, there's, see, it will not follow me over for some strange reason. Let's see. Right, back up here. There's your atomic number and there's your atomic mass. So when you fired an alpha particle, the atomic number goes down by 2, so it decreases by 2. See that? Decreases by 2. There's it there, but that's not really shown on the screen. Right? So what happens to the mass number? That's the top number. It decreases by 4. See the way I'm using the language that they use in the table? Now, what happens at beta, right, there's your naught E minus 1. Did it move over there? No, it didn't. Well, it'll increase by 1. Your atomic number increases by 1. And the mass number, no change. Now, if you go back through other videos, you'll see parent-daughter particle. And that tells you exactly what to learn. Right? So the other two have no change in them. So there is the answers. I want a nice clean table with those. Oh, there's one line missing there. See, that's what I told you about this pen. Sometimes it likes to work and other times it doesn't. Right, so now I'm going down to question number 8. Maybe zoom out a bit. Didn't put them other things in for me. That's all grand. Learn for the next time. It says copy and complete the following equations for alpha decay. Now remember, this is what I was talking about there. There's your parent nucleus, and it decays to a daughter and an alpha particle, 4,2He. And what did I tell you? These numbers, follow the blue spot, these numbers add up to give you that number. And these numbers add up to give you that number. So if I put A and Z there, well then this one has to be Z take away 2. Z take away 2, add 2 gives me Z. A take away 4, add 4 gives me A. That's the general equation. Fair enough? Let's have a look. Can we do the question? Uranium-92 is going to emit an alpha particle because it's unstable. So it goes to an alpha particle. And thorium. So this number here must be 90. And this number up here must be 234. And it's just went off the screen. Fair enough? And it's just disappeared. 234. So that's the first one done. Next one. Plutonium, Pu 96 goes to uranium 238. I'm just putting the numbers in the question. And an alpha particle. Fair enough. Now that number there must be 94. Hold on, I'm wrong. That should be 90. That's 94. And that's 94, so that has to be 92. That's 92. 92 and 2 gives me 94. I took the question down well. 238 and 4 is 235. 238 and 4 is 242. 242. Fair enough. Made a real hymns of that one. So let's go through it again. 92 and 2 gives me 94. 238 and 4 gives me 242. Now, let's see, can I get the next one? I think that's californium goes to curium and an alpha particle. So it's californium 251, got that right, goes to curium, and there's a 86, these aren't focusing too well today, and 42He. Now, this number and this number gives me this number, so that must be 98. This number and this number gives me that number, so that must be 247. 247. Fair enough. Now HF goes to yttrium plus an alpha particle. Now let's see, can I put in the numbers that I need here? So I know that's 170. Tells me in the question, you see, look at the question. All else fails, look at the question. So that's 70, and that's 2. So that there must be 72. That's 170, got it off the question, and that's 4, that must be 174. Fair enough. Again, that 4 doesn't look that clear. And I've done it twice. Fair enough. Let's go on to the next one. Bismuth splits, and it goes to tellurium plus an alpha particle. And it tells me in the question that that's 81 and that's 207. So go the numbers along the bottom should add up. So that has to be 83. And that must be 211. Fair enough. Now let me just check that I got those right. Yep. Now, going up to, again, you work down the page. I'm going to cross the page because I'm not going to use a wallop of pages for this. So you should be working down the page. Fair enough. And we'll do the last one. F PT 190 goes to osmium 76 plus an alpha particle. 2 and 76, that should give me 78. Some number add 4 gives me 190, so it must be 186. Hang on just to undo that. Undo. Thank you, machine. 186. So I'm at 186 and 76. Right, so that's them done. Now I'm going to do question number 9. And question number 9, I'll top turn the page, tells me that it's a beta decay. So remember I talked about parent-daughter particle, right? Parent, daughter, and particle. And this particle in this case happens to be a beta particle, not E minus 1. So remember A cross zebra. So that must be Z plus 1. And that one's just A. That's the general rule. So with the general rule, you should learn that. God forbid if we ever learn anything. So let's do the question number 9, and we're talking about carbon 14. That's the fancy isotope of carbon 12. That gives you carbon dating. See, the pen is just today, it's decided that it's going to do its own thing. It goes to nitrogen and a beta particle. I'm trying to watch 3 things here at once, so it's fun, I can tell you. Like the minus there is missing. Right. What number has this got to be? 7. 7 take away 1. You wouldn't even see the 7. 7 take away 1 gives you 6. So the top number is 14. 14 and 9 gives you 14. Still not even writing. Pen's still going to wobble today. Still not writing. Fair enough. Now let's do this hydrogen. Hydrogen changes to helium and a beta particle. Just check that. You wouldn't even think that was helium, Lord knows. The pen is just glitching today. That's a 3 up there. So, what's this one? 3 and nothing. Follow the blue spot. Gives you 3. 1, so that must be 2. 2 take away 1 gives you 1. Fair enough. That's tritium, an isotope of hydrogen. You should know that. Right, I'm trying to do these and it's not very successful. Right, cesium goes to barium and a beta particle. Right, so it tells me this is 137. So if that's 137, then that has to be 137 because still writing again, thank you pen, 137, that's 3 times, see that number there, that's 137, 137 and naught is 137. Now it tells me that the bottom number of the barium in the book is 56, so that's 56 take away 1, that has to be 55. Can't understand why the pen works somewhere and not others. Right, let's do the next one. Potassium goes to calcium and a beta particle. And it tells me the potassium is 19, so the calcium has to be 20. Because 20 take away 1 is 19. It tells me in the question that the calcium is atomic mass of 40. So the potassium goes 40 plus naught is 40. Now the cobalt disintegrating to give you nickel. and a beta particle. So it tells me in the question that the nickel has an atomic number of 28 and atomic mass is 60. So the cobalt must be 27 over there and 60 up there, because 28 take away 1 is 27, 60 add 0 is 60. And the last one, the phosphorus splits to give you sulfur and a beta particle. It tells me the phosphorus is 15, so that must be 16 there, because 16 take away 1 is 15. It tells me this over here is 32, so 32, that has to be 32. 32 add 0 is 32. Thank you, machine, you're just letting me down today. That's 32 there, see where I'm pointing? I can't, and that's 30, I have it written as 32, but the pen won't just do it today. And finally, question 10. It says, work out the type of decay in each of the following examples. It tells me bismuth, 213, that's the atomic mass, goes to polonium, 213. So that number doesn't change. See, follow the blue dot, that number doesn't change. So it must be a beta particle. It must be the naught E minus 1, because look, the naught. Come back, you brookie. Undo. Don't know why it does that. Right. Radium changes to radon. Radium changes to radon. Goes from 226 to 222. Believe it or not, that says 222 with the machines, right? So that number there, I'm pointing to it, goes down by 4. So it's an alpha. Remember, 4, 2, He. And francium goes to actinium. So francium is, where am I doing? 221. And it goes to 217. That's irritating that. Trying to look about 3 things at once. 217. So that number there, now the pen won't even match it up, that number there has went down by 4. So it must be an alpha. A 4, 2, He. I apologise for the pen here, because the pen has let me down with these small numbers. But what I want you to do now is question 7, 8, 9, 10 and 11. I'll let you do number 11 yourself. I want you to do these to a high standard. I want you to upload them to me within the time I'm given. I'll mark them and send them back to you. So you've seen them done. It's now time for you to do them. I'll talk to you shortly. Toodle pip.